Good morning, everybody, and welcome to the How IX Capture Can Simplify Aerial Capture. We are 3 minutes to the start of the webinar, and we will wait 3 minutes, and then we will start the webinar. Good morning, everybody, and welcome to the webinar on how IX Capture can simplify aerial capture. My name is Oodi Menaker, and I'm the product manager of IX Capture, IX Flight, and IX Plan. And I also manage and execute the flight testing of phase one cameras, so I have hands-on experience in collecting aerial images. We'll start about phase one. Phase one is a world-leading provider of medium format digital imaging systems and solutions. And we concentrate on industrial applications and professional photographers. We focus on the imaging accuracy for aerial imaging and machine vision. And this is why our cameras are all calibrated and they keep the calibration parameters for a long time. We have a large range of products with the camera starting with 50 megapixels to 190 megapixels and with a broad range of lenses from 32 millimeters to 240 millimeters. For recording of images, we have the ruggedized fanless IX controller, and we have a range of software to support from flight planning, flight execution, triggering, capturing the images, and working on the images themselves. All our lenses are specially made for phase one medium format cameras. So all of them take into account the special sensor dimensions. The cameras are cost-effective alternative to large format cameras because they are small and their weight is low relatively, and they cover a very large swath. We have RGB and NIR solutions, and we can synchronize multiple cameras. The cameras are UAV ready. They can be connected to USB 3 for storing the information, and also you can store information on CF and EXIF card. And there is a hardware interface for waypoint mapping. The software solutions, IXCapture is used for management and processing. IXPlan is for flight planning. IXFlight is for the flight management. It gives direction to the pilot where to fly, and it triggers the cameras. Capture One is used for image improvement. We also have SDKs, and the IXLink SDK is used by usually by integrators that want to have their own solutions. So the outline of this webinar. We'll first speak about what is the need that drive us in the development of the IXCapture. We'll speak about parameters affecting the image quality, how to set up the cameras pre-flight, whether it's one camera or multiple cameras, how to control the image parameters in flight, and how to process the images after the flight. I already seen that there was one very good question. I'll answer all questions at the end of the presentation. You're all welcome to send us questions through the webinar. So what is the need that we're trying to solve in IXCapture? We need to set up and control the camera in flight. So today, many cameras cannot be reached in flight. They are either in the back of the aircraft or they are under the GPS and are under the IX controller. Even if there is an interface, you cannot access it. So you have to have some way of controlling the camera. Our new cameras don't have a built-in screen and user interface, so the only way to set up the camera is through IXCapture. After the flight, we want to have geographical understanding of the image locations. And we want to export the images from the IIQ compressed format to TIFF and JPEG. And we want to do a combined RGB infrared, and we want to process the 190 megapixel images. All this we want to do in batch handling of large number of images with minimal user interaction. So you can come back from the flight, download everything to the server, start it, go home. In the morning, you'll get 2,000 images processed for you. What are the parameters that affect image quality? First one is ISO. ISO controls the sensor gain or amplification. We need to remember that when we control amplification and when we amplify a signal, we also amplify the noise. So we have to be quite careful with this. The recommended values for day operation for RGB cameras is usually 64 to 400. The less is better, but depending on the sun conditions that you fly in. In RGB, up to 800 ISO is acceptable. You won't see much visual effects up to 800 ISO. If you're flying with NIR cameras, you will probably have to be at 400 to 600 because the NIR cameras have a filter that filters out the red, green, blue, so we're not left with much energy there, only the NIR. So we have to increase it to about 400 to 600 usually to get a nice picture. The aperture. The aperture controls the opening of the camera, the opening of the lens, and actually the amount of light. It also affects the depth of field. So recommended values for day operation are 5.6, for the RGB day operation are 5.6 to 11. When we go to higher number, we get smaller aperture, it's less light, more depth of field. So if you're flying over a city and you need to do a place with high risers together with small buildings, you want to have a large depth of field. If you're flying over rural areas with everything is flat, you don't really need the depth of field. All the cameras are calibrated to infinity. So any number 5.6 to 11, whatever suits the need for the nice picture. Next is shutter speed. The shutter speed controls the speed at which the shutter will open and close. It affects the amount of light, and it affects the sharpness. It affects the sharpness because of two reasons. First of all, when we open the shutter, the aircraft is still moving, and it can do 1 centimeter to 3 or 4 centimeters, depending on your speed, while the shutter is open. The fastest the shutter speed is, the less distance the aircraft covers during taking the image. So faster is sharper with the shutter speed. Another issue that a high shutter speed solve, sometimes we have strong vibrations. If we're hard mounted on a helicopter, or if we're hard mounted on the floor of aircraft that has vibrations from the engine, the higher the shutter speed, the lower the vibration affect the image quality. The combination of these three sets the exposure value, EV. The exposure value is a value that tells us how much light do we have in the image. And now for the settings, the pre-flight settings. We have two ways to control in flight the image settings: auto exposure and manual exposure. Let's start with the manual exposure. By clicking on manual exposure on the right-hand corner of the capture screen, you get to and then by clicking on settings, you make the in image the manual active, and this is when the manual active, it is orange. On the tab, on the upper tab, you see here the name of the camera, and you see a green dot. This green dot says that this camera is connected now. You may have multiple tabs here if you connected to your IXU controller several cameras. The active one, those that are operating now, will show with this green dot. So you select here, you go here, and this is manual because this is what you selected. And now by clicking on ISO or shutter or aperture, the ribbon opens and you can select the value. That's all. So you go through ISO, shutter speed, select the values. If we want to go to auto exposure on the capture screen, we click on auto exposure, and then in settings, you'll see that in the image area, the auto exposure now is orange, which means it's active. And then you set the minimum and maximum values for ISO, shutter, aperture, and you set the priority, meaning the order at which the camera will change the parameters. A word about how auto exposure works. Auto exposure actually works inside the camera. The camera is trying to get the exposure value to around 0 or a different level. I'll speak about it later. And what it does is it takes the image, it looks at the image, and if the exposure value, let's say, is too low, it will increase the ISO. Next image, it will increase the ISO again. Next image, it will increase the ISO again till it gets to the required value. If it reaches the maximum ISO, it will start changing the shutter, and then it will start changing the aperture. Now, whether ISO will be first to change, or shutter will be first to change, or aperture will be first to change, and who will be the second. This is what you set with the priorities here. You can get aperture to be the first by just clicking twice here and here, and it will be the first to change. Now you put the values here, the same as once you click, there is a ribbon opening and you put the value. If you want to set a specific value, you just set minimum and maximum to be the same. Now, if we have multiple cameras, they will all appear here, and you see that they all appear in tabs, and they are all connected. They are all connected, so we need to know which camera we're setting. It is very recommended to insert a meaningful name here. And in this example, you see 6 cameras in the oblique configuration. So we put a meaningful name, and then we see a meaningful name above, so we know which camera we are setting. It is pretty hard to control 6 cameras in flight, go one by one and change them. And that is why we group the cameras. We group the cameras in setting system. You can group the cameras. It's setting system. You group the cameras, and we have 3 groups. You can change the name of this group while you're working. So here we have nadir, forward, aft, left, and right. And by clicking on the relevant camera, it becomes part of the group. Now, once you change parameters for one camera in the group, it changes for all the group. And you can put all the cameras in one group, and in flight, you'll change everything by clicking on one camera. Advisable or not, up to the user. You can put them 2 groups, nadir and side looking. This is more probably more relevant, and then you can change for the nadir and for the side looking during the flight. How we control the image. So this was the setup in pre-flight. Now to the flight. We control the images in flight using the EV marker and the EV history in the upper side of the display. The exposure value history recommended value is between 0 to -1. It's usually on -0.5. This is the good place to get the exposure value during capturing. In manual exposure, you click on manual exposure, and then these controls are alive. And by clicking on plus and minus, you can control each of the parameters in any order that you want, or any value that you want to get the EV history and still get good images. Remember the basic rules that ISO, you don't want to be too high. Aperture, you want to be between 5.6 and 11. Shutter speed, the highest, the best. Now you see here, this screen is dark. It's good for an aircraft where the operator sits in a dark area. We also have a light screen for aircraft in which the operator sits in an area full of sun. To move between dark screen and light screen, you go to setting system, and this is where you select the type of screen. When working in auto exposure, the way to move to auto exposure is by select auto exposure in the capture screen. Once you select auto exposure, then ISO, aperture, and shutter are grayed out. You cannot control them because the camera now has the control. However, if you see that your images are too dark, for example, you can still tell the camera, move the target value of the EV. So you push here plus and minus on the EV, and this is the way you give the camera another reference when you do auto exposure. So this was how we control the camera in flight. Let's go to the post-processing. And the first step is to review image location and parameters. Then we usually create TIFFs and JPEG. If we have RGB and NIR camera, we want to create CIR, and I'll go through the workflow. And if we have 190 megapixel images from the IXU-RS 1900, there is a way to create them, and I will go through it now. So in order to review image locations and parameters, we have in each directory of the images an EXIF log. It means that every camera has an EXIF log that shows all the parameters for the images of this camera. The EXIF log has the file name, the GPS time, both in UTC and in week seconds, longitude, latitude, altitude. Altitude is altitude MSL, as we get from the GPS, pitch, rolio, and the camera parameter, ISO, aperture, and shutter speed. What I usually do is I take this file, it's in CSV format, I put it into Global Mapper, and I get a map of the mission. So I get the location of the images and the name of the images. Now, when we fly, we usually take 2-3 images on the ground just to make sure that everything works well. We make 2-3 images before we at the vicinity of the flight area, but before we enter the passes. With this map, I can see exactly which images are not part of the project, but they were taken before the project, and I don't need to process them, and I don't need to give them to the customer, and sometimes I just delete them from the file. So this map helps me to get exactly the files that I need. Now, the basic thing is to create TIFF and JPEG. You can export TIFFs and JPEGs from the IIQ, the compressed format in which we keep the images. You can also do a distortion corrected RGB. For distortion corrected RGB, you need to import the calibration that we deliver with the camera to those who purchase calibrations. So you would select the type of output file you need, check on RGB, check on distortion corrected RGB. Either import the file that you got or put in the parameters manually if you want, and then select either images or the full directory. Click on Start Processing. It will get you to processing screen that will give you monitoring on the process, where you are, which image is running now, and where are the images that are done. Let's go to RGB-NIR processing. RGB-NIR are usually made by two phase one camera. One of them is RGB, the other one is NIR. You can see the NIR has the filter on top of it. This is the NIR camera. Important things, the inter-camera orientation during the mission must be fixed. If the cameras are installed one on one wing and another on another wing, and each picture is in different orientation, it will be very hard to combine the images. That's why we recommend that they are co-located on the same plate. It's very recommended. They must shoot in sync, so the sync cable must be connected between them, and they need to cover the same area. when we operate it, both cameras are presented to the operator, and they can control the parameters of both cameras, and it can set the values such that we will have good images in both camera. The automatic process we do in order to generate the CIR, and again, this is automatic, this is not something that the user does. The software does distortion correction, type point selection, and then it creates a transformation from NIR to RGB. Now, if we don't have a way to find type points, we will not be able to create the transformation from NIR to RGB. So if the NIR image is very blurry, black, unreadable, we are engineers, not magicians. We will not be able to create out of it anything. So the NIR image has to be good, the RGB image has to be good, and then we find type points, and we create a transformation from NIR to RGB. Then we do resampling of the NIR to match the RGB pixels, because we can handle, for example, a 150 megapixel RGB with a 100 megapixel NIR. We match everything to the RGB. The RGB is the master. Once the resampling and mapping of the NIR to the RGB is done, we add the fourth layer NIR to the RGB pixel, and this actually gives us the 4-band NIR RGB layers. And then from this we create, some customers want 3-band CIR, so it's a NIR red green, or 4-band CIR NIR red green blue, and NDVI maps. This is all done with no user interaction. The process of the workflow process in IX Capture, you select here CIR. Camera, it's usually single head. Only the 190 pixel are multiple head. This is single head. The type of selected output type file you want, TIFF or JPEG. Save the folder where you want to put the information, and then check mark on each of the products that you want. Import the calibration for the RGB and NIR camera. Import the selected images or selected directories, and click Start. Now, about the import of selected images and directories. If you have GPS event ID in each of the images, then, or GPS time in each of the images, you can just select the directory of the RGB and the directory of NIR. We will match each NIR to its relevant RGB image. If there are issues with the time or you did not have GPS connected, then we need you to tell us which RGB image correspond to which NIR image. And then the way to do it is by select images. When you click on select images, we will open two windows. One of them is for the RGB, the other for the NIR. And we assume that the order of the RGB, or actually the order of the NIR, correspond to the order of the RGB, and you set the couples. So this was CIR. Now to the IXU-RS 1900. This is a large frame camera with 16,470 pixel cross-track and a CMOS sensor and a 90 millimeter RS lens. This is actual large frame camera that weighs like a small camera. It's not 80 kilograms or 250 pounds. It's like 3 kilograms, but it's still large frame camera. The lens calibration orientation is written in the camera, and it's written on each image during the production, we put it into the camera. The flight operation of this camera, to the user, the image is presented as if it is stitched. It's not stitched. We just place one image near the other image, but the user in the flight sees one large frame image. This is how he can know whether it's a good image or not, and he can just, like a regular camera, work on the change the ISO, aperture, and the shutter, and control the exposure value of the image. Some things that are must are sync connection. Those two heads must be synced, and it's very recommended to connect the GPS to the camera. It helps the syncing. If you don't have GPS connected, please do not connect any wire to the port, and then we will generate a sync signal between the two images. The processing workflow, and again, this is done automatically with no user interaction. We do distortion correction. We find tie points in the overlap area between the two images. We create transformation between the two images and diffuse the two images into one image. This is all done with no user interaction. How we do it in the software itself, we select system RGB, the camera, it's multi-head camera. Select the output format type, import the files, and click on start. It will lead you to processing, and this is how you get the files done. The processed image parameters, because our images are only the first step in the long work of getting DTMs or building vectors or other vectors from the images. So we know that our images are going into other products later. So you need to know the parameters of the images. Distortion-free images, they all retain the focal length of the source. So if you're exporting IAQs to a TIFF and you do a calibrated image, they retain the focal length of the source image. The XP and YP is moved to 00, to image center. 3-band CIR and 4-band CIR, they retain the focal length source of the RGB image, because as I said, we match the NIR to the RGB. So the focal length of the RGB is the master, and the CIR image will retain the focal length of the RGB. XP and YP again are moved to image center 00. For the IXU-RS 1900 large frame TIFF, the image focal length is the left image, not left camera, but left image, the master image. When you get the certificate, calibration certificate, this is what's written there, the focal length of the left image. And the XP and YP is set to the center of the image, again, 00. Now, we do have a very explicit manual with a lot of information. The manual is available on the net. It's on industrial.phaseone.com. Downloads, quick start installation and user guide, IX Capture 3.2 user guide. It's in PDF, so it's searchable, very easy to use. With this, I will go now to your questions, and I will read the questions and give an answer for each question. So the first question was, can IX Capture be used to fire multiple sync camera in IXC mode, not in FMS mode? Well, IX capture can be used to fire multiple sync cameras. However, the trigger signal from IX capture is not going through the sync wire. It goes through the USB 3. So you will not get perfect synchronization within what the operating system sends, because we send the trigger to the operating signal to the operating system. The operating system sends it to each camera by itself through the USB. Our experience show that this is within probably 150 to 200 milliseconds. This is not really synchronized. So if you really need synchronization, please do connect a sync cable and a trigger to all the cameras. That's the difference. So you can activate multiple cameras through IX capture by clicking on the trigger, or in IXC mode, you click on the trigger, it will trigger. But remember, you send a trigger individually to each camera through the USB. This is not a sync operation. This is based on the operating system timing. Within 200 millisecond max, you will get all the images. Not good enough. And this is the reason why we do recommend to use hardware trigger and a sync cable. Is there a way to apply image? Next question. Is there a way to apply image correction from Capture One before CIR4 band composition in IX capture? Is it possible that process like XML correction files or profiles for Capture One? Not yet. Not yet. We're working on it. In one of our next versions, we will apply the COS. We will read the COS files from Capture One. Right now, we do not apply the COS files from Capture One. The only way to do now image corrections is to correct the images in Capture One, export to TIFF, and import the TIFFs into IX capture for production of CIR. It's cumbersome, I know, and this is we are working now to implement reading the COS file of the Capture One and taking it into account. So all changes that you did in Capture One will be taken into account in IX capture. Another thing we're working now and will be available for the next release probably in February timeframe is haze reduction, automatic haze reduction in IX capture. You will be able to check mark, and IX capture will automatically do haze reduction on all the images. Next question. For image preview window during capture, is it possible to change the position of the titles to match their actual orientation? Left, right, back, etc. Right now, no. I will be thankful if you send this question to my mail. It's OME, Oscar Mike Echo, at phaseone.com. We can discuss exactly what you need, and we can see if this can go into one of our next versions. We need to keep in mind that although we provide users that buy systems from us with screens, but there are a lot of users that have their own screens with different resolutions and different some use 4:3, some use 16:9, and we have to accommodate all of them. It's not that easy to make the screen accommodate, to make our display accommodate all screens and be able to move different parts of the display to different places, and this is why it is right now. But I'll be more than happy to look into specific requests and try to accommodate them. At the end of the day, you are the users, and we want to have happy users that like our software. I don't see more questions. So this presentation is recorded, and the recording will be available within probably 2 days on our site. So thank you very much for taking part in our webinar. I hope you will find the information useful to you. Thank you.